Hey, hi everyone. Wrong camera. Let's make myself bigger, shall we? How are you doing? Oh, that's not right either. Apologies. There we go. Hello, my name's Dr. Phil Winder, and I'm the CEO of Winder AI. So this is going to be a very, very informal presentation, a bit more informal than normal, because I have a workshop that I gave at GoTo Copenhagen a couple of weeks ago, all about AI engineering. And I thought it'd be useful to start recreating some of that online for everybody else to see. So this is going to focus in on one particularly interesting aspect of integrating AI into your applications, and that's the element of testing and evaluation, and specifically how you do it. And I'm going to present one tool that I think you might find useful. I'm going to talk about a couple of techniques that you might find useful. But of course, if you've got any questions throughout this, then this is live, so you can just ask questions in the comment section of the platform you're viewing in. It should pop up on my screen, and I should be able to answer it in real time. So yeah, definitely do chip in if you've got any questions to ask. Okay, so I'm just gonna start preparing myself here by adding that. So yeah, this is the what should we do? Let's put my face up there. This is the repository that I have placed all of the content from today, and we're going to be specifically looking in this section number 2, evaluating and benchmarking. So you can check out github.com/winderai/AI engineering course with dashes in. If you're interested in following this along, or coming back to this at a later date, then this repo will still be here. You'll be able to read it offline. And also check out Winder AI, our website, for more interesting articles, and if you're interested in any of our services. Okay, so let's get rid of that. That's not a very good way of doing that. There we go. All right, so let me crack on. What's this all about? So yeah, I'm going to split this up into sort of 3 or 4 distinct sections, probably going to take about 45 minutes. And I'm going to focus in on evaluation, basically. That's the theme. And the reason why it's interesting is because fundamentally testing and evaluating AI-driven systems has changed the development life cycle. So traditionally, software engineers would write very deterministic tests, and they still do, and I still do. And those deterministic tests, usually comprise of some code and then some assertions based upon the inputs and the outputs of that code. And that is that's the way it's always been. That is test-driven development. That's the way it's always been. I did start to see a few years ago the concept of fuzzing, which was this idea of if you had a parameter that could change in some dimension. So if it's a string, it could obviously have different text. If it's a number, it could be a different value. The concept of fuzzing in software testing is the idea of trying lots of different permutations of those inputs and verifying that the output is right according to some rule. If you take that a bit further, you can kind of think of LLMs as the same sort of thing. It's a very fuzzy black box where passing something in, but we're not sure what we're going to get out. And one of the main reasons for that is that the underlying non-determinism in AI applications, and that comes from a variety of places. But I think maybe let me just show you some of this non-determinism in action. So just share this screen. Okay, there we go. So we've got just a prompt here, and hopefully you can see that. Might make that a bit bigger, actually. Not any better? Not really. All right, so this was just a simple for loop to pass in a prompt to Olama. Olama is running locally on my laptop. I'm running just a really small model, Qwen 3 1.7 billion. This fits very nicely on my my old Mac M1 Air. And we're asking it to loop around and explain why Paris is an important city in 10 to 15 words. I'm doing that 10 times. And if we look at the outputs, we'll see that each output is subtly different. There are similarities between them. So I think the first thing is that if you look at the first word, always says Paris. You look at the first 5 words, always says Paris is a cultural and historical. Oh, nearly apart from that one. So this is saying that the terms Paris is highly likely in the corpus that this model has been trained upon. But everything after that starts to get a bit more fuzzy. Sometimes it's seen the words like cultural and historical with a comma. Other times it's seen cultural and historical. And then from then on, it starts to get even more fuzzy. This 1, 2, 3, 4, 5, 6, 7th word, center, capital, hub, center, capital. That's completely different because it was, predicated by the previous comma, capital, hub, center. So you can see there's some distribution of similar words being used there. But each time we kind of take one step away from the norm, it then generates even more fuzziness after that. And the net result is you get, nearly, in fact, are there any similarities in there? Are there any lines that are exactly the same? Nope, that's not the same. That one and that one are the same. Okay, so we've got at least 2 examples that have produced the same result there. And that non-determinism is actually what we want. That's what we're asking LLMs to do. We're asking them to predict words, and generate probable, realistic content. And so we want it to infer. We want it to predict. And so if you need that behavior in your application, then we need to think about how we can control it. Okay. So one of the ways that we can control it is by altering some of the parameters in the underlying API call. And so I think to demonstrate this, I think what I'm going to do is I'm going to write a few curl requests with a couple of different settings. Right, so the first one, let me show this one actually. This is good. Okay, so clear that out. Hopefully that works. Yeah. Okay, so this is now calling the REST API of Ollama. And what we're doing here is we're passing in an option to the Ollama API. So this API is specific to Ollama. It's not like an OpenAI compatible. But OpenAI APIs have something very similar. They have something called a seed. And a seed is an element in an underlying system's random number generator. So it's the number that it starts everything from when you're asking it to create random numbers. And if you set that to be the same number each time, then the idea is that there are any randomness in the underlying algorithm where it's using randomness of the system or randomness of the underlying library, then that should cause the result to not be random anymore. It should produce the same result each time. Now, the interesting thing about that, as you can see, actually, let's just talk about the result. You can see that the result is consistent each time. It's generated the same response 10 times. So let's maybe try that again with the Paris example and just make sure it also works for that. So I'm just going to edit that request now. So again, we're getting consistent results, which is fantastic. However, the seed is not enough, because one of the one of the things that you can do, this is a great example. So instead, I might need to download it. So I was using the local API here. This is the local Llama instance that's running on my desktop. But what I can do, hopefully, is run a Docker container. Yeah, just to take a second to download. So this is going to run the same Llama instance, and I'm going to download and run the same model, hopefully if it's fast enough. And then we're going to repeat the same request with the same parameters again and see what we get. Come on, let's go, let's go, let's go. Well, to avoid any dead air, maybe what I can do is talk about what you're going to see. What you're going to see is that when you switch systems, when you switch architectures, or when you switch even distributions, you can get different results. And yeah, the reason for that is underlying hardware differences. So the chipsets that actually form the elements of the computer that you're using might have subtle differences, which have like a cascading effect on the software that is running on it. And another thing is if you switch the inference runtimes. So if you're going, for example, from a CPU to a GPU, or a CPU to a TPU or something, same thing again, different set of chips, different set of processors, and they all have different ways of working and different rules. At the most crude level, some of the chipsets have different bits in some of their floating point computational chips. So you get like, overflows in the floating point numbers, which then manifest in the parameters of the neural network, which then manifest as a different prediction at the output. Okay, so that is just extracting now, and then what we'll need to do, I think, is just double check that that is running on the right port when it finishes. Come on, come on, come on, come on. Sorry, I should have pre-downloaded this container. Must have, I constantly run out of room on my desktop because of all the Docker containers, so I regularly prune them and remove them. Yes, right. Okay, let's run that. Okay, great. So we've got model. Oh, is that? That's interesting. That looks like my local models. Sorry, wrong one. Let's try curling 11434. Oh, same. Oh no. Okay, well, I'm not going to sit and debug this in front of you, but the idea is that I'll maybe just try and run it, see what happens with the code that I've got printed. Yeah, using the API here. Oh, okay, great. Maybe it is targeting the right thing. Oh, am I? Oh, that's why I shared the my home directory. I wasn't expecting those models to be there, but because I've added a Docker volume to share the Llama directory, then it's got access to all these other models. Right. So when I ran that against, yeah, one of them. Anyway, I got a totally different result. So the first time it was Olivia, now it's changed Elias. But the actual request, so temperature to top K seed, temperature to top K seed, temperature to top K seed. Yeah, so they're all equivalent, and we're getting totally different results. So point is that the parameters of the model are not enough. You can set the seed, which sets the random number generator. You can set the temperature, which affects the amount of variation in the output probability distribution of the word. So basically how consistently it picks the same most probable tokens. And yeah, top K, which is another parameter for selecting the selection of words which comprises, which can be chosen by the algorithm at runtime. Even if you set them and fix them and set them to a very deterministic value, is not enough. Okay, so the whole point of that is to demonstrate that no matter what you do, there is always a lot of uncertainty in the output of these models. Doesn't matter how much you corral it, doesn't matter how much you prompt it, doesn't matter how much you change the settings of it, you've got to deal with that inconsistency. So how do you do that? Okay, so let's set a, what should we do? What should we do next? Let's talk a little bit now about let's do some examples of some of those parameters. I think that's probably a good use of time. Right, so we talked about the different settings there, but let's see some examples of that in action, because they do help, obviously. All right, so the first one is the temperature. I talked about how the temperature it controls the randomness in the model's output. So if you make it lower, then it makes the response more deterministic, whereas higher values increase creativity and variation. So that's the first one. Let's run it again. We haven't set the seed here, so we should get slightly different results each time. Interesting, which we're not. That's very interesting. Sorry, oh, hang on, wait a minute. Have I got that the wrong way around? Sorry, I got that. I said that the wrong way around. Sorry, a low temperature, yeah, increases the. Yeah, there we go. So the temperature setting is the opposite of what I said. That's not useful. So if you increase the value of the temperature, you're asking it to be more random. Maybe I did say that. But you see each time that with the temperature is set to 1.5, we're getting a different answer each time, because it's changing the probability of picking the next word. It's kind of like, think of it as a distribution. So think of a normal distribution. Think of the point in the middle, the mean, as the most probable word. The most probable word is probably, well, you know, so let's look at the third word. We've got bread and brew. So bread is possibly the most probable word in that. And then just beside that on the distribution are other words like brew or other things. And so by increasing the temperature, we are sort of flattening that curve out and making all of those tails more likely. So it's kind of jumping around that distribution. Okay, so that's temperature. We've also got top K. So yeah, so thinking of that distribution again, top K, sorry, did I say top key? Oh, top P, sorry. Top K is next. Top P is a setting that limits the model to only consider tokens that represent the top P% of a probability mass. So if we pick a value of 0.1, we're saying that it must contain basically the most probable tokens within that. And you can see that even though we've got a temperature that's quite high, we're basically limiting the pool of words that can be chosen. So think of that distribution. We've got that mean again, which is maybe the most probable. And what we're doing is slicing both of the tails off and only keeping that one word in the middle. So it actually makes it quite consistent. So if we change that to be much more liberal, so use a value of 0.95, then we should see that we're getting some completely different values. Yeah, look, it's starting to hallucinate quite badly now, actually. Let's go like super crazy and just turn it up to like the maximum. Oh, look at that. We're starting to get emojis. Yeah. Okay. And then top K is a similar thing. I mentioned that earlier. Top K is picking the top number of tokens. So if you pick 2, for example, it will find the 2 most probable tokens. Yeah, so it's rather than, because if we do it by probability, top P, then you might only include 1 probable token. You might include 5, 10, depending on how the tokens are distributed throughout the data. Another thing that can help is to prefer shorter responses. So you can specify that in most APIs. So in Llama, it's numPredict. This is really useful when you've got a task like a classification task or something, and you know that you always must have the data respond in like 10 characters. If you say like true or false or something like that, you can set that to limit the response. Yeah. Okay. And there's also a repeat penalty in some APIs as well. So you can set that in Llama with the repeat penalty. So this is, sorry, I should have cleared that first. This is controlling how often tokens are repeated within a sentence. 0.75 is kind of like a may repeat, whereas setting it to 1.5 is telling it should not repeat. So I think hopefully we should be able to notice that. I think probably the first thing that we notice is that it's shorter, it's more concise. We've got the word exercise probably multiple times in that one. Let's have a look. Exercise 1, 2. Okay, so it did repeat exercise twice as well. Anyway, yeah, hopefully you get the idea. And the greater the value there. What happens when we make that really big? Let's try that. I'm not sure what the valid values are actually. Looks like there's a diminishing returns on that penalty value. Okay. So yeah, maybe just talk about sort of guidelines. So you need to think about what type of task your application is trying to achieve. If you are performing some kind of factual or analytical kind of task, like a classification task or like question answering possibly, or anything that requires more consistent results, then you probably want to reduce the temperature. So 0.1, 0.3, something like that. You probably want to reduce the top P or top K equivalently. Values maybe 0.3, 0.5. And the whole goal is to focus on consistency. Yeah. For more creative tasks, so if you've got an example where you want to create text for some reason, then you probably want to allow a bit more flexibility. You want to increase that temperature to near 1. You also want to increase the top P or the top K in order to introduce more words. But the top P here is actually quite crucial because it depends very much on what the model has been trained on. If you go too high with those values, then it will start spitting out. So, for example, a lot of the Quen models, even when you're talking in English, there is some probability that it will suddenly switch into Chinese because it was trained on a lot of Chinese data. So you need to be a little bit careful about your values there. So use higher values for variation and creativity. Then there's kind of like a range of tasks that sit somewhere in the middle, and coding assistance is one of them. So if you've got a task that requires some creativity, but still, data-based, a data-backed approach to solving the problem, then you probably want somewhere in the middle. So temperatures of around like 0.4, 0.5 or something, top P around 0.5 as well. So you're trying to balance that out. Okay. Probably the only thing, just whilst we're here, it's probably worth mentioning the only other important thing is the context length. So many models have maximum limits for context in length inputs and outputs. So that's the amount that you can pass into a model and how much you can get out. If you're hosting your own models, then it has a dramatic difference, a dramatic effect on the amount of memory that the model is being, that the model is using. So also think about attempting to minimize your prompts and minimize the inputs and outputs as much as possible. Okay. Right, next, let's talk a little bit about hallucination. And this kind of comes up a lot because people see it as a bad thing. But like I said right at the start, we want these models to generate text. We want them to be creative and we want them to make things up. So we can't, on the one hand, say, don't hallucinate. On the other hand, say, be creative. It's obviously a compromise. And this is what evaluation is all about. It's about trying to control that. And one of the main reasons for hallucination is that you're asking it to do things that it has no knowledge of. It has no context. So for example, it's just a couple of examples. So we've got one here. Okay, so this time I've run this a couple of times, and sometimes it does kind of hallucinate this. Maybe we could add in some temperature prompts here, but it does sometimes think that Dr. Samantha Rodriguez, the Nobel Prize winner in AI for 2025, is a real character. But this time it said, it's fictional, but she is often used in. Oh, okay. So even though it said at the beginning that it knows it's a fictional character, it's just continued like she is a real person. Okay, so that's good. That's a good hallucination. Yeah. So how can we what can we do to start controlling that? So one of the first things in that sentence is that it's inherently uncertain. So for example, what's the population of Atlantis? It's inherently uncertain question. And what we can do is add an instruction to that to say, if you don't know, tell us. Simple. It's really obvious and really simple, but yeah. Basically add that prompt to everything that you do. It's such a no-brainer. Okay, you can ask the model to verify its own statements. So this is an extension of the previous one. But it applies a little bit of verification to its answer before it presents it. And that helps guide the output prediction towards the right answer. And thinking models, you see that I keep passing think false, actually. We could probably, let's just take that out. Thinking models actually do this inherently, and that's why they generally perform a bit better, because they already implicitly think about what they're going to write before they write it. So think of the output tokens here as a kind of a guide, like through a maze that's guiding the agent to the eventual correct answer. And so here it has interesting. Okay, let me just run that again. Actually, I can't. I'm not even sure if that's wrong. I think that's wrong, right? It was only released this year, I think, wasn't it? Oh, rubbish. What's wrong with that? Oh. I wonder if it's pulled some new weights recently. Okay, let's change the question slightly. I think that's a slightly old question because well, let's find out, shall we? What year it was GB released? Yeah, okay, I was right. Sorry, I was just going a bit mad there. So yeah, GPT-5 was released in August, on the 7th of August, 2025. So what's interesting about this response is that each of these answers has specified 2024. Yeah, okay. So that prompt hasn't even worked, which is a great example of a failing prompt. Let's run it a few more times and see if it gets the right answer. No, it didn't. Wrong. 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 Okay, let's change the answer. Change the question a bit. Okay, all right. Well, maybe it's the size of the model. If we used a bigger model, it'd probably have a better time. But point is, this is the first sort of basic what's the term for it? I forget the name of the react of a react loop. It's the ability to kind of think about what it's doing and then react to it. Okay, all right, move on. Also, another good idea is to include the ability to add citations. And you can do that in a number of ways, and that really helps ground the results. So you know how we mentioned how the output of a prompt is kind of like guiding it towards the correct answer. Think of it as a process of you trying to lead the output towards the right answer. And with citations, that really helps. So if you're doing some sort of RAG, or if you're getting external information, then you can include that in the response, and you can say, please write out your citations first, your actual verified truth, and then generate your answer from it. But you can also even just ask it to label things as fact, and that also really helps to sort of ground the result towards the response as well. A couple of other ideas. So let's move on. We're taking a bit of time here. So where are we? Yeah, so chain of thought is an extension of what we just talked about. And yeah, also, yeah, temperature we talked about. Okay, yeah, perfect. So you can see basically this was a demonstration of how prompting can really help ground the results and guide the agent towards a more accurate and also a more consistent result. But the question remains, how do we evaluate this? Well, there's two ways to evaluate this, two main ways. The first one is to benchmark, and there's another section in the repo that talks about benchmarks. Benchmarks are basically curated sets of data with scripts usually that you can run against LLMs to quantify performance. So think of them as tests. So they'll ask maybe the data set will be like a question answering data set. So there'll be a question and an expected answer. And then typically these benchmark frameworks use another LLM to determine whether the answer that was generated is correct or not, and then you measure the results. So that's one way. Another form of benchmarking is through the use of people and people's opinions on which is the better result. So there's a couple of websites out there where you can compare the sort of qualitative results from various models. But the other key form of testing is through evaluation and evaluation frameworks. And I want to introduce a project called Promptfoo. So let me just show you this on here. Okay. Right, so there's a couple of websites you can look at. Probably the best one is, here we go, is on GitHub, and then you can probably go from there. So if you go to github.com promptfoo/promptfoo, it's also got a accompanying website as well. Yeah, and the main product is this NPM node-based front end for managing all of your tests. So I'm going to show you a quick demo of that right now. Okay, so first what we'll need to do is install Promptfoo if you haven't done already. Let me just find the right screen again. Okay. So I'm just going to see if I can make this a bit bigger. I'm not sure how to do this. There you go, like that. Oh, let's make sure I'm doing that as well. Sorry, I should have done that earlier. Okay, so we're installing Promptfoo globally with NPM. This should install most recent version of that. Okay, and I'm just waiting for that. Ooh, I hope they are just warnings and not. I'm going to quit that just in case that kills the demo. Anyway, that's how you would install it. And then we've got this file here. And so Promptfoo can be driven from the UI, and I'll show you that in just a moment. But it's also got a really nice YAML format, which allows you to get a bit more of a CI sort of driven process to this. So you could integrate this into your CI if you wanted to. Basically, it's a definition of a test that you want to do. You pass in the specification of the provider you want to use, this list of potential models, then the prompts that you want to test, and the tests that you want to perform. So the crucial things in this are the prompts, obviously. So this is where you can, it depends on your task. So it depends what you're doing. Maybe you're comparing your prompt against a series of different providers. Maybe you're trying to optimize the size of the model being used to prefer smaller models. Or maybe you're comparing different providers on OpenRouter. Maybe you're trying the implementation, testing the implementation differences between different providers, for example. Or maybe what you are doing is some kind of prompt engineering, and you are trying to improve your prompt. So you can maybe test against different ideas for prompts that you've got there. And then generally the tests kind of stay the same. We specify them here in this big list. We have variables that are passed in to the prompt, and then we have a list of different assertions that test needs to pass in order to be successful. There's lots and lots and lots of different potential assertions that Promptfoo can handle. The contains one is basically, does the output contain this particular word? I think that's it for this. But yeah, if you go to the Promptfoo documentation and go to the assertions and metrics, then there's lots and lots of different types of metrics in there. Probably the most important ones to look at are so you've got a lot of deterministic ones. So basically like code driven ones, equals, contains, things like that. But you've also got lots of LLM powered metrics as well. So for example, this one is a fact check, a factuality check, and you specify the fact that you want in text as the value, and then the Promptfoo will use a model to evaluate that. Okay, right. So now we're going to run, not that one. We're going to run our YAML by running Promptfoo eval. Hopefully that works. It's got the right path. Oh no. Okay, maybe I do need to install that. Oh no. Oh no. I think I accidentally half killed it. Let's maybe try and clear it out. Come on, work. Yes. All right, let's try that again. Come on, work. Yes. Can't believe that installing a project is a major success, but yeah, it is. So I ran the Promptfoo eval command, lots of different commands you can run. This is using that YAML file that we just looked at and running all of those evaluations. So it's running it against, again, it's running it against my local Olama instance. So don't expect the results to be amazing. But what we should see after a short while is that it has generated 6 results and evaluated it against the compare assertion, and we'll be able to look at those results. So obviously in real life, you want to try and get good coverage with your tests, just like you do with software engineering. You want to try and cover as many of the most common things that you're asking your agent to do. Obviously, that's easier for some tasks than it is others. So for like a classification task, it's generally quite easy because there's potentially not that many classes that you need to classify them for. But in like an email answering application, for example, you could get a huge variety of different potential emails that you need to write, and therefore it would be quite hard to get good coverage over that data. But as always, you need to have a data-driven approach to all of this and do some analysis on your own data to find out what the core groupings are, and then generate test cases for those groupings. Seems to be struggling on that last one. Come on. I think obviously the other thing to notice here is that the LLM inference still takes quite a long time. There we go. Right. So now that has run, I've finally got something to show you. I can run Promptfoo view, and then we can browse to the address that it shows, and then I'll quickly switch screen. And here we go. This is the UI that shows the run that we have just performed, and we've got the values that were passed in as part of the test, and we've got the answers on the right and whether the test actually passed the rubric or not. And in this case, it passed all of them. 6 out of 6, which for such a small model is amazing. Only, a year ago, this wasn't possible with a 1.7 billion model. So quite impressive. Okay, so let's have a look at a slightly more advanced example now. All right. In this example, we have we've pulled out 2 different prompts into JSON files. So we've got an advanced prompt and a basic prompt. And then we have some more complicated tests as well. So we've got a latency test. So this is checking that the response returns within a certain time frame. We've got another sort of contains, but this time it's a list. And also we've got a slightly more sophisticated code-driven evaluator here. And this is quite interesting because you can run arbitrary code. It's all written in JavaScript, so unfortunately it needs to be written in JavaScript, but that's okay. You can write some quite sophisticated tests there if you need to. So here I'm just lowercasing the text and asking that it includes either the word technical or bug. Also, we've got contains JSON. So this is testing whether the output contains JSON, specifying some output path there as well. Let's have a quick look at the different prompts, actually. Let's see. So that's basic. Where are you? Oh, it's because it's in here, isn't it? There it is. Classify this email. So that's basically a simple prompt that we saw last time. Oh. No. There we go. And this is the slightly more complicated one that implements some of the ideas that we talked about previously. So we're being a bit more specific. And also we're providing a lot more instruction and examples as to how we should achieve the task. All right, so let's run that as well. I think so. There's only a couple of, 4 tests in there. So fingers crossed it shouldn't take too long. All right, whilst that is coming up, I think maybe what I'll do is quickly, if you are interested in this topic, I do have a dedicated page for this here on the Winder AI website. So if you go to winderai.com/blog, there's a post there testing and evaluating large language models in AI applications. And there's a bit more of a review of basically a summary of what I just said there. So check that out if you're interested. Okay, in the meantime, we are nearly there. All right, and I think we can should be able. I don't know if we have to specify the. I think it should just pick up the last one and show my browser again. Okay, and oh, that is interesting. One fail, one pass, one fail, one pass. Okay, so we failed all of our test cases now on both prompts, which is oh yeah, it's the latency. That's what killed it on both of these examples. Okay, and both of them failed to contain technical JSON. To contain valid JSON, sorry. Okay, well that's fair enough. We can relax some of those tests. But that was just a demonstration of what it looks like when you start getting a little bit more complicated. So yeah, obviously in a real life application, you have many more tests. And so you only really, you kind of have to search for the test that you're interested in order to view that. Lots of filters there to help you do it. We can also compare different runs that we've done in the past. Oh, it's also remembered a lot of the historical ones that I've done in the past as well, which is interesting. Okay. Right. So that was Promptfoo. But the question is like, all right, you could just go through and generate like all of these test cases, but actually, like in a real life situation where you have very if you have an application that requires quite a diverse set of use cases or a diverse set of tests, then it can be quite burdensome to actually go about and create all of those tests. And so one of the key things that you can do to get around that problem is by generating some synthetic data. This also helps with like PII. If you've got any PII in your data, then you probably don't want to be incorporating that into your test. And so by generating some synthetic data, then you can be somewhat certain that it doesn't include real PII. However, that's interesting because obviously the models themselves have been trained upon PII data that exists on the open internet. It's quite likely that it could generate some real, data. So yeah, beware of that. I've got a script to do this. So how do you go about actually generating synthetic data? Probably one of the simplest ways to do it is to write your own script, or not even write a script, but just write in a prompt. Just go to your favorite chat LLM provider and ask it to generate data for you. So I've got an example here, which is a script that generates a load of different emails based upon some predefined categories. So the goal here is to evaluate the classification of an email for like a downstream process. So what we're going to do is start with that classification and then ask the LLM to write some emails. So in this case, we've got urgent issue, supply order, schedule, customer, and these are kind of like seeds that the LLM can use. And obviously these are all LLM generated as well. But you can see how you can generate a large number of permutations there based upon some simple known facts. And what that allows you to do, especially when you're doing prompt engineering, prompt development, it allows you to very easily kind of navigate like how you're affecting the application by altering your prompt. Maybe you're like simplifying it. Maybe you're producing like a smaller number of tokens, or it's faster, or performance is increasing, but it might be like in a particular category. So for example, in the maintenance category, maybe you're losing a lot of accuracy in that particular category. So that's really, really useful. We can run that code to generate some data, of course. And then what we can do is we can, I think, do I already have that? Yeah, I already have that, I think. Let me just double check that it still exists. Yeah, I have that. Let me just quickly show you what that looks like. Synthetic data. No. There we go. So these are the actual emails that got generated by that script. And you can see it's in sort of Promptfoo format. We've got, the variables that are specified inside the prompt, and we've got the assertions that we want to do on that. And we're just asserting that it contains the same the expected class. Okay. Next, let's run that. Let's oops, where have I gone? Sorry, I'm just finding my notes again. Closed the wrong thing. All right, so we want to run that against Promptfoo now. We're still using the very small model. Oh, we are specifying some config now, which is interesting. And we've got our prompt there. But the new line here is that we're passing in synthetic emails as a JSON file. All right, so let's run that. This is probably, yeah, that's going to take, oh, did I? Oh, okay, that's much faster than I thought it was going to be. Oh. Okay. So I fixed the maximum number of predictions to 50 tokens. So that's why it's much faster now. It's only producing 50 tokens each time. All right, so that finished. Let's view the results one more time. There we go. And we can see that 56% of these tests are passing. Let's have a quick, so let's show the failures only. Okay, let's have a quick look at the passes only. So urgent, supply, customer are all doing quite well. There's one supply there, but let's ignore that for now. Schedule or maintenance doing really bad, and other. So maintenance and other are both doing really bad. So this is a perfect example of how, you know, it might not be a completely realistic test, but it gives you a lot of information in the direction that you need to improve your prompt. So clearly, for some reason, that prompt is not categorizing maintenance properly. And it kind of makes sense. You know, you can probably go back to the domain. Like a maintenance issue, a catastrophic maintenance issue is probably an urgent issue. So we can probably go back to the domain and actually regenerate the classes that we're interested in classifying and improve results that way, rather than, you know, just hacking away at the prompt too much. But anyway, it doesn't matter. This is just an example, toy example, but it's just an indication of how this kind of analysis and synthetic data with testing and evaluation can actually help improve your application. Yeah, I guess that's the key thing. So what next? Yeah, I think I'm probably just gonna stop there because I've been talking for ages now. Oh wow, nearly an hour. Yeah, please, you've got a few seconds to get any questions in. So if you've got any questions, then do send them in. I haven't seen any yet, but if you've got any, please ask them now. In terms of conclusion then, so start small. Always start with the simplest prompts that you can get away with, and ideally start with a small set of tests as well. Let's get rid of that. If you can use Promptfoo or another tool like that, you can validate your work as you're developing it. It's basically test-driven development. It's TDD for AI. You can refine your prompt with new examples. I recommend that you actually write the examples yourself first before you resort to synthetic data generation, just to get a feeling for how prompts kind of react with more realistic data. Once you are at a point where you're happy with the prompt that you're using, then move on to potentially start gathering more data. If you've got real data, then fantastic. Incorporate that as best as you can. So one way of doing that is you can gather some real life data and ask a really, 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 really big model to generate the correct answer for that model, you know, depending on how you're actually configuring the assertion. And because it's a really big model, it's probably going to be, somewhat correct or more correct than maybe the model that you're using to develop this. Yeah, I think the studies have been shown that bigger models are a good supervisor of smaller models. So yeah, you could do that if you've got realistic data. If you don't have realistic data, real data, or you don't have much of it, then you can synthetically generate that data. I didn't mention any of the projects. There is a really quite a cool framework that I've completely forgotten the name of now. I think it was an IBM project. Let me quickly see if I can search for it. Oh, I found a page. Lab, is that it? Oh, they're not giving me a link to their GitHub page. Anyway, there's a library that I saw a while ago from IBM that helps you to curate data and then generate data based upon that curated data set. So that was a pretty interesting project. But the simple solution is to use another LLM, usually a big one, to generate some new data for you. You can write a script for that and generate it from that, or you can just use a ChatGPT, Claude-like UI to generate that data for you. Get it in the right format for Promptfoo, and then use that as your evaluation set. I think once you've done that, you're probably 80% of the way there. I mean, then it starts to become like diminishing returns. It's the same with software engineering, right? You can write millions and millions of unit tests, but at some point you get to a point where there's enough to kind of cover general uses of the application, and any more is just a maintenance burden. So whenever you change the prompt or you change the data shifts or something, you're going to have to maintain that and update that. So beware of adding too much, because then it becomes a maintenance burden. But obviously that depends on the mission criticalness of your application. Okay, let's stop there. So once again, if you're interested in any of this, then you can go and visit the full website, Winder.ai/AI engineering course. Let me show that again one more time. There, so that's the link. Make that a bit smaller. Still too big. And then you can find the full course. So it obviously helps if you've got someone to talk that through with, but feel free to browse that website yourself. And also check out the Winder.ai website. That talks more about, doing AI in general. One final shout out as well. If you are interested in doing any of this, but on premise, so if you're working for a company that has private or secret data, then it's really important to protect that. And you can do that by running helix.ml. That's one of our products. It's an on-premise AI platform that allows you to run AI workloads entirely locally on your own hardware or in your own private data centers, things like that. There's some really cool stuff going on there around agents and especially coding assistance as well. So yeah, check it out if you're interested. All right, I'll stop there. And if you've got any more questions, then feel free to reach out and email me. I'll post a video of this shortly. Probably a simplified, shortened version of this talk shortly on the website. I hope you've enjoyed it, and I will see you next time. I'm planning on doing one more talk in December. I'm going to do that over Christmas, I think. So keep an eye out on the Winder.ai events page to be notified of that. I'll see you next time. Thanks a lot. Bye-bye.